Internal Routing Protocols Part 5, Advanced OSPF Configuration across Non-Broadcast Multi-Access Networks. This nugget is to focus in on making OSPF work across the frame relay style of network. Now, when I am teaching at a CCNP level, this information is usually covered in a course called Building Scalable Cisco Internetworks, or BSCI. And this is the section of the course that I absolutely dread. The reason why is I'm sure by now you've seen many of the OSPF modes across non-broadcast multi-access networks, and you have to admit the first time you saw it, you probably looked at it and like me, you were going, what? It's just mind-blowing, and you have to go over it again and again and again to really get it down. And that's what I intend to do in this nugget, is to walk you through each one of the 5 non-broadcast multi-access modes that OSPF can run in, and I want to give you practical configuration examples to go along with it. I'm also going to focus in on tuning OSPF, not only focusing in on setting the modes up, but also verifying that it's working correctly, looking at a lot of the show commands we can use to do that, and also, when you get to the CCIE lab, they may do something very cruel to you. Let me show you. Oh, let me get my freehand drawing tool here. They may take a network where you have a router connected to a cloud and we've got multiple routers connected, and they may say, well, use one type of OSPF mode here and another type down here. Now, in the real world, would you ever do that? No. But as Cisco says, the CCIE lab is not a lab of best practices. It's a lab to make sure that you know how to make this work successfully. And some of these modes are compatible, even though they're different modes. So I want to show you, if you do run into a situation where you have to make one mode of NBMA work with a different mode of NBMA, how you can tweak the timers in OSPF to make those work successfully. Well, let's start off with the big one, configuring OSPF over non-broadcast multi-access networks, which in most cases will be frame relay, and you can start seeing ATM networks emerging in some of the larger companies. And the reason this is so difficult is because OSPF is so flexible. They give you so many options, especially on Cisco routers, to configure OSPF to support over these frame relay networks, that it just becomes baffling and mind-boggling. Which one do I choose? Does this one work with this one? Can I combine these modes? Do I have to pick a mode for the whole cloud? I mean, all these questions swarm your mind. So let's talk about each one of these one at a time. And that's one of my goals in this nugget, is to really give you a practical example of each one of these deployments in a live environment, so you're able to see how to configure it, some of the show commands to verify that it's working okay, because this is one of the core pieces of your network, running OSPF across frame relay. So there's 2 different umbrellas of modes that we can encounter. RFC standard modes, which work on Cisco routers and any other routers supporting OSPF and non-broadcast multi-access networks. And then Cisco proprietary modes, which just work between Cisco routers. So let's start off with the most difficult one that I've seen to configure, non-broadcast multi-access, or NBMA mode. Now this mode, I'll kind of jot some notes on the screen here for you for each one. This mode is the default mode on any multi-point interface, or if you choose to configure frame relay on the physical interface, not using any sub-interfaces, this mode will be the default. If you want to change it, you'll have to use the IP-OSPF network command. It also, since as its name implies, it's NBMA, it requires that you statically define your neighbors. I'll just put static there. Because it is non-broadcast, it will not allow broadcast or multicast across the cloud, which means your hello messages aren't going to happen in a normal format. It will convert it to unicast by you statically typing in your neighbors. And also, this one treats the cloud as if it were a broadcast style network. And what I mean by that is that there is a DR and there is a BDR that is elected. And you will influence that through your static configuration. And it's kind of counterintuitive when you think about it. You're thinking, okay, non-broadcast, but it treats it like a broadcast network by electing a DR and BDR. That is true. However, in this instance, on an Ethernet segment, the router that becomes the DR and BDR isn't really that important. You can leave it up to random chance and, hey, you know what? If that 1700 series router becomes a DR, that's okay. It doesn't really take that much more to be a DR. But in the frame relay network, the router that becomes the DR, and BDRs are essentially optional at this point, the router that becomes the DR is very important. It's critical that that DR be connected to every other router in the cloud. It needs to have that full connectivity in order to be a DR. So we're going to look at ways to influence that election and make sure that the right router becomes the DR. Now this next one right here, I'll put a little star by it because this is my second favorite mode to configure. It's so easy. Point to multi-point. What happens is, let's say we have a multi-point interface. We've got a router up here connected to a frame relay cloud with 3 other routers attached, one interface. What happens is when we turn on point to multi-point mode on every router, it will go ahead and treat each connection as if it were a point-to-point link. Now, looking at the name, I kind of grin and I think, point to multi-point treats it like point-to-point. It's kind of funny, but that's how it works. There is no DR that is elected because it thinks they're point-to-point connections. And it is dynamic. It will be able to discover these neighbors dynamically because it will just send hello packets down each one of the DELCs. It does some other things for us as well. It will create by itself magically static routes for each one of these neighbors. Now you remember when you're configuring frame relay, we talked about it in one of the way early nuggets. If router 1 up here wanted to reach router 3, you would have to configure a static mapping to say to get to router 3 go through, we'll say router 2 right here. That's the central router. Go through router 2 and then go down to router 3. So you'd have to configure mappings so that these spokes know how to reach each other through the cloud. Not with point to multi-point. It works in a snap. It will go ahead and generate routes via OSPF. Enter your routing table. They will be host routes with 32-bit masks that point to each and every neighbor. This mode, I can't say enough about it. It rocks. So that's my second favorite mode, so you're probably wondering what my favorite is. It's not this one. Cisco proprietary modes. Broadcast will treat the frame relay or non-broadcast multi-access cloud just like it would in Ethernet segments. This one will have a DR, it will have a BDR, and it does require that every router in that frame relay cloud have full connectivity to every other router. So when you see broadcast, think full mesh, which most of the time you won't have unless you have a very wealthy company that's supporting all those virtual circuits. This one is my favorite, point to point. And I think it's just because of my design of frame relay. Whenever I set up frame relay for a company, I don't care if they just have one DELC. I set it up for a point-to-point sub-interface, a point-to-point circuit using that frame relay interface DELC and type it in there because it's just so clean. If they ever add more DELCs, each one is looked at as a point-to-point circuit, and it's just beautiful because our router sees each one. It's its own individual interface. It's not a WAN link that connects to multiple neighbors because that's really a strange connection if you sit down and think about it. WAN links are meant to be point-to-point, and when you create a point-to-point sub-interface on your Cisco router, say you do serials, put the dot in the wrong place. Let's say we do serial 0.1 point-to-point. It's immediately going to put it into OSPF point-to-point mode. And provided the other side is a Cisco router and is also using a point-to-point interface, they just take care of themselves. There's no DR, no BDR. Everything is sent to the all routers OSPF multicast address 224.0.0.5. It just takes care of itself and it runs. So point-to-point, easiest to configure, and it's my personal favorite in that configuration. Now, I would say the least popular one is this one, point to multipoint, non-broadcast mode. Cisco just tweaked the RFC standard, and they said, you know what, this mode is great, but it requires, since it's using multicast, it requires that you have a broadcast-based network, as in the frame relay cloud will allow multicast and broadcast across it. So this is the same configuration, you just statically define your neighbors. I'll just put static there. You statically need to type in each one of your neighbors, and it works just like the point-to-multipoint mode. The reason it's the least popular is because who controls whether multicast or broadcast will cross the frame relay cloud? Well, most of the time, if you control the network, you do. I mean, the service provider is just passing packets. They don't really know what kind of packets they are. You are the one that says whether or not broadcasts are allowed. So if you're going to configure OSPF to run across the cloud, most of the time you'll just use this and not really worry about statically configuring your neighbors if you wanted to do a point to multi-point mode. So that's a 10,000-foot view of each one of those NBMA modes that OSPF supports. Now let's get into the configuration. I want to show you how each one of these is set up and the show commands that you can use to verify that it's working correctly. Okay, so here's a view of our quite colorful OSPF topology. You can see that I've broken this up into 4 major areas. Area 0, which is the frame relay cloud. Area 1, 2, and 3. And the interesting thing is the areas aren't going to be that difficult to configure at all. That's really not what is important here. The importance comes from the configuration of the frame relay network. So let's focus in on that. We have router 1, which is the hub of a 3-spoke frame relay network. We have serial 0/0.1, a multi-point interface, which is connecting down to router 2 and router 3. Now, based on some requirements, router 2 and router 3 cannot have sub-interfaces, so we went ahead and configured frame relay directly on the physical interface. So they are, at that point, a true multi-point configuration from the physical interface itself. Now in router 1, serial 0/0.2 is a point-to-point interface, and it's coming off down here directly to router 4. So that'll allow us to see a point-to-point OSPF network as well, which is pretty straightforward to configure. So let's go ahead and get going with the configuration on router 1. As of right now, I don't have anything set up on there, so let me do a show IP protocols, verify there's no protocols running. Router OSPF1, and I'll do a router ID 1111. Network 170.100.100.1, that's that multi-point interface up there. 0000, focusing just on that, and I'll put area 0. Let's also take care of the other 3 interfaces while we're here. I'll go ahead and jump up here and do the 200.1 in area 0. And finally, well, probably easier to just retype it at that point. Network 10.1.19.0, we're not too sure what that interface is. Area 0. So we'll put all that full network into the OSPF configuration. So now when I jump out here, I'm going to type in a show IP OSPF interface, one of the key commands that we need to verify what sort of state our network is running in. And we see up here, Fast Ethernet 2/0, which is the interface connecting off to router 9. This one is up. We actually have the network type in broadcast mode. So that's what we'd expect to see for an Ethernet segment. Let's come down a little bit. We see, oh, we got some messages interrupting this, so let me do another show command here. Serial 0/0.2, which is the point-to-point sub interface, and since it's a point-to-point sub interface, we see network type is going to be a point-to-point. So it's recognized that network type. And as I hit space, I come down to the interface that is going to be the tough one. Serial 0/0.1 is up. Network type is non-broadcast, or an NBMA. That's the default network for any sort of multi-point style interface. Now, one thing I want you to notice while we're looking here in this show interface output, or show OSPF interface, we see the differences in the hello timers. We see a point-to-point network, hello 10, dead 40, wait 40, retransmit 5. We come down here to the non-broadcast network, and look at that. 30, 120, 125. The timers are different. So what does that tell you? Instantly, you should realize that, hey, if we have a network mismatch, one is a point-to-point, one is a non-broadcast, we're not going to work here. We actually are going to have different timers, which means OSPF is not going to form a neighbor. For OSPF to form a neighbor, we have to have exactly equal timers. Now, there are going to be some modes that we see that are compatible somewhat. And for instance, this one right here is not compatible at all. A non-broadcast network, NBMA, as we just saw, Alexa DR, Alexa BDR, if we were to try and combine one router with this network and a router with this network type, we'd be totally incompatible even if we manually adjusted the timers, because point-to-point doesn't elect a DR, it doesn't elect a BDR. This one does. They're 2 totally different networks. We're going to see some that can be compatible, but may require you to adjust these timers manually. So we have this configured on router 1. Now, in order for router 1 to work correctly, I'm going to jump back to the topology here. Since it's in the non-broadcast mode, NBMA, we have to statically define who the neighbors are, and then we need to make sure that router 1 becomes the DR. Why? Because it has the full connectivity across the cloud. It is the one that can connect to every other router. It's the only one eligible to be the DR. So not only do I need to make sure that router 1 is the DR, but it's just a good practice to make sure that router 2 and router 3, well, router 4 is on a point-to-point, so we don't even need to worry about that. Make sure that these two routers are ineligible to become a DR or a BDR. You don't want these pretending to be a DR when something is, router 1 goes down, or even to try and be a BDR, because they don't have the connectivity that's required. So let's go into interface configuration mode, and looking at that multi-point interface, serial 0/0.1, IP OSPF priority, and let's peek this one out, 255. We're going to set the priority for this to become the DR way up. So when it starts negotiating the neighbors on that interface, it is for sure going to become the DR. Now let's jump into router OSPF configuration mode, because this is where we statically define our neighbors. I'm going to type in neighbor followed by the IP addresses, and let's look back at our topology. We have serial 0 here, which is going to be 170.100, 100.2, and .3 are our two neighbors. So I'll type in 170.100.100.2. Let's make sure we've got everything. You can also statically type in what the priority of that neighbor is, what their pull interval, how often you're going to say hello to them, the cost. Really, when you configure the neighbors, they're going to unicast and they're going to contact each other. So you don't really need to worry about setting the priority as long as you've done it correctly on your neighbors. You could set their priority to 0 right here to make sure they don't become the BDR, or when we go and configure those neighbors directly, we can do it on those neighbors. So I'll type in the two neighbor IP addresses that I'm going to communicate with. Look back at my diagram, make sure I'm okay. Okay, we should be good to go. We're now ready to hop down to router 2 and router 3 and set up them. So let me bring up the configuration window here. Get back out of router 1, jump down to router 2. And let's set up router 2 for OSPF. I'll do a show IP interface brief so we don't have to flash back to the topology, although we may end up there in the end anyway. Router OSPF 1, router ID 2222, and I'll do network 170.100.100.2 area 0. Okay, network 170.100.2.1, that's the Ethernet interface, and that was, we're going to flash back, area 1. So we've got that configured. It's an area border router. Now here's something that a lot of people believe. Oh, before I even tell you what people believe, let me get into serial 0, IP OSPF priority. What's it going to be? Zip, zilch. We're going to keep this thing from becoming a DR or a BDR by typing in the priority down at a level of 0. That makes it completely ineligible to communicate as a DR or BDR on that segment. So I'm going to do a show IP OSPF interface, a very handy command to use when we're starting to work with the frame relay network. Ethernet, that's fine, we don't really mind about that one. Serial 0 is where I'm coming in, and we see right now the network type is non-broadcast, and the state is waiting. State is waiting. Let's do a show IP OSPF neighbor. Nope, as of right now we're not getting any neighbors. Let's ping, make sure we're reaching 172.100.1. Interesting. So if the state is waiting, why is it not negotiating the neighbor relationship? Let's troubleshoot here. Let's hop back up to router 1, show IP OSPF neighbor. It should see those static neighbors that I've typed in. There's the 9999, that's my Ethernet segment, and that's okay. We'll let that one handle itself. And down here we have the neighbor IDs. It hasn't communicated with them yet. It hasn't reached 170.100.100.2 or .3. Those are the static entries that we've typed into the database. Oh, there it goes. It just popped up. Neighbor has been negotiated, gone from loading to full, so it just took a little time. I'll hit the show IP OSPF neighbor again. And there we have it, 999, that's the Ethernet, and we have formed a full relationship with the multi-point network. Now notice this, it says DR other. Even though router 1 is a DR, and even though router 2 down here is the second router to come into the mix of things, it is negotiated as a DR other rather than a BDR because it's ineligible. So, that took a little time to negotiate, huh? Show IP OSPF neighbor, and sure enough, on router 2, we are seeing it as a DR, and look at that. It found its priority because it unicasted between them and exchanged that hello packet in a unicast format. So router 2 should be good to go. Let's hop over to router 3 and do the same thing. Config T, and before I even go too far, I'll go into interface serial 0/0, and I will set the IP OSPF priority to 0 so I don't forget. Router OSPF1, router ID 3333, network, oh, I can't remember. Network, we're on router 3, 170.100.100.3 and 170.100.3.1. Now, if I get those jumbled up, I won't be surprised. 170.100.100.3, area 0, network 170.100, oh, dot 3.1, okay, area 2, dot 3.1, area 2. Okay, so we should be good there. And notice, I want you to realize something, because this is something I've seen a lot of people do. Did we statically type in the neighbor on router 2 or router 3? Did we type in neighbor and type in the IP address of router 1? The answer is no, we did not. What's going to happen is router 1 will proactively come down here and contact router 2 and router 3. You only need to type it one way. Now, can you type it two ways? You know, just for consistency's sake? In my opinion, it's best not to. I've had it work, and it has worked successfully for me when I've typed them in both ways, but I've also had it where strange things have happened, where it doesn't work like it's supposed to. So when you're statically typing in your neighbors, make sure that you only type them in. My recommendation is to type them in from the hub. Don't really type them in on the spokes, because we'll let the hub go down there and take the responsibility of contacting those neighbors. So I'm going to jump up to router 1, which is the hub, and just do a show to see if it's formed that neighbor relationship. Now, at this point, if you were in the CCIE lab, you would start sweating because you'd be thinking, well, where is it? How come it hasn't formed yet? And you get very anxious. I have stumbled myself so many times. I've gone through the configuration. I get anxious, and I start troubleshooting before it's time. Look at that. Poof, it popped up while we're talking. That took, what, 30, 45 seconds? If you were too anxious, you would go in and start removing the neighbor and changing configurations before you waited for that to form. Make sure you give it some time, especially with the NBMA networks. It forms quickly on most others, but where you statically configure the neighbor, it may take some time for that neighbor relationship to form. So at this point in time, we now have router 1 speaking to router 2 and router 3 on an NBMA relationship. I'm going to do a show IP route on router 2, and what we see here is that we are receiving the route 170.100.3.0, which is down here. So on router 2, we're receiving this route from over at router 3. Okay. Now I'm going to do a ping 170.100.3.1, which is the one right behind router 3. And notice what's happening. It's timing out. The reason why, and this is a big catch, if you're using point-to-multipoint mode on OSPF, it will fill in those host entries. Because as of right now, it's saying, okay, to get to this network, what's the next hop? 170.100.100.3. And this is just following the logical troubleshooting steps in my mind. I'm thinking, okay, well, if to get to this network, it needs to go, well, let's look at our diagram. Where is this? That's the next hop. Is that right here? No, that is down here, 170.100.100.3. So, does it know how to get there? Can it get that far before it even tries to get to that Ethernet network? Let's find out. 170.100.100.3. Look at that. It can't get to the next hop IP address, which is this one. So, forget trying to go all the way to the Ethernet. You can't reach router 3, and the reason why, as I was beginning to say, I'll do a show frame map, is when I did my maps, or I should do a show frame PVC. When I set up my PVCs, I did not set this one up with a mapping to go from router 2 to router 3. I only set it up with a mapping to go from router 2 to router 1. Now, when we go and configure points in multi-point mode, which we'll do in a second, that is all we'll need. But in this case, I need to set up a frame relay mapping because I'm using NBMA mode. I'll get into serial 0/0, or I think just serial 0, yep, on this router. Frame map IP, and we'll say 170.100.100.3. That's the next hop IP. And the DELC, router 2, that would be DELC 201 is the one that we'll use to get to that router. And we'll allow broadcast to go around that. Okay, we need to jump over to router 3 and do the same thing. Interface serial 0 over here, 0/0, frame map IP 170.100.100.2, followed by, let me check it here, 301 is the DELC we'll use to get there. Allow broadcast there as well. All right, because you not only have to go there, you have to get back too. So now, at this point, when I do that ping, I should be able to reach that IP address. Do you see what I just did there? I had to put in those static frame relay maps. OSPF does not take care of it for me when I'm using non-broadcast multi-access mode or non-broadcast mode. So I'm able to ping the next hop. So at this point, I should be able to ping that Ethernet interface. And I am. Excellent. So that's a good logical walkthrough, step-by-step troubleshooting of how to troubleshoot that NBMA mode. And it gives you some characteristics of the NBMA mode as well. Now, you know what scares me is what we just did right there. We just did the frame relay map to allow those networks to be reached. Let me do a show IP route one more time just so I can get a fresh routing table up here. Before we even did those frame relay maps, this network was here. Usually, a router that cannot reach the next hop will not put it in the routing table. However, router 2, before we even did that frame relay map, thought it could get there. Do you get that? It looked at its IP address, it looked at its subnet mask, and it said, you know what? I think I can get there. I think I can reach that IP address. So it threw this in the routing table. And until we pinged that network, we didn't know if that really existed or not. We might have just looked at it and said, oh, good, it's getting the route. Life goes on, you move on. But remember, when you're going through this step-by-step, always test your connectivity. Just because it's in the routing table doesn't mean that you can reach it, especially when you start dealing with these NBMA networks. So always, always, always make sure you ping those next hop IP addresses. Okay, let's jump on off. Let's jump over to router 1, and I'd like to focus in on this point-to-point network, which in no way will be as difficult as the NBMA side. As a matter of fact, I'm on router 1, right? I'm done. That's all there is to it. When I set up OSPF on here, I turned it on for all the interfaces. So let me do a show IP OSPF interface. And right there, serial 0/0.2, since I created this as a point-to-point sub-interface, it will assume point-to-point network for OSPF. So my only chore left is to jump down to router 4 and set it up for point-to-point. So we'll be able to see that process take place. I'm going to jump down to router 4, do a show IP interface brief. Serial 0/0.1 is a point-to-point interface, so I'll get in router OSPF1, router ID 4444, network 170.100.200.2. Area 0, network 170.100.4.1. Oh, and what area was that? That was area 3. All right. So at that point, we have a point-to-point sub-interface. I'll do a show IP OSPF interface. Sorry, my mind blanked out for a brief second there. Serial 0/0.1 line protocol is up. Network type point-to-point. It's assumed since I created that point-to-point sub-interface, I'm going to have a point-to-point OSPF neighbor. Let's see if we've formed that neighbor relationship yet. Show IP OSPF neighbor. And sure enough, it's there. Oh, and by the way, just so you know, you might wonder, well, how come on some routers, like you were sitting on router 1, and it popped up saying, hey, OSPF neighbor relationship has formed, gone from loading to full. How come it didn't do that on this one? Well, on router 1, it has a little more modern version of the iOS, and on router 4, I think it's just one rev lower. But there is actually a command from router configuration mode. Let me jump up there and show it to you. I'll do a show run. In router config mode, it's typed in by default. I didn't have to type it in. Log adjacency changes. if that command is typed in, we could very well type it in on every router. It will report it to the screen as the neighbor relationships form. But at this point, router 4 should have the entire routing table from all the other routers. And oh, pop up my menu there. I'm so excited. It should have all the other routers that have formed neighbor relationship and all the routes in its routing table. It should be able to ping completely around the network. See, now, do you see why point-to-point is my favorite? It's just so simple to set up. It's just assumed whenever you have a point-to-point interface. So what I'm going to do is I'm going to pause the recording. I'm going to yank off the NBMA configuration from router 1, 2, and 3. And I'm going to reset that up as a point-to-multipoint configuration, the other RFC standard, which does treat all of these as individual point-to-point links. So give me a sec. Let me yank that off. Right. In that blink of an eye, I went ahead and yanked off the non-broadcast multi-access configuration on router 1, 2, and 3. As a matter of fact, I just did a no router OSPF 1 and completely disabled OSPF. Now, to save us some time, I went ahead and set OSPF back up on router 3 and partially set it back up on router 1. I set it up to connect to this point-to-point network and to router 9, but I haven't configured the multi-point interface as of yet, because that's what we're going to focus on right now. So let me jump back into the virtual terminal, and I'll do a show IP interface brief, get my bearings. And right now, I'm going to configure serial 0/0.1 as a point-to-multipoint network. So let's do that. I'm going to go into global config, router OSPF1. I've already set up the router ID. I'll do network 170.100.100.1. area 0. And now I'm going to go into interface serial 0/0.1, because that's the multi-point interface, and type in the one command, IP OSPF network point to, and you can type in point to multipoint or point to point. So I'll type in point to multipoint and hit enter. Now, do we need to set the priority on router 1 to make sure that it becomes the DR? The answer is no, because remember, when we were talking about the characteristics on the initial slide into this nugget, we were talking about point-to-multipoint not electing a DR or BDR. Check this out. I'll do a show IP OSPF neighbor. I was glancing at the status messages in the background, and what I see here is that I have 9999, that's router 9, not really worried about that one. 4444, that's the point-to-point neighbor, that's full. And look at this, 3333. That one is full, but there is no DR or BDR because we are running a point-to-multipoint configuration. So let's go ahead and jump out and set router 2 up. Router 2, again, to refresh you, is the one sitting down here. As of right now, it has no OSPF configuration. So I'll do router OSPF 1, router ID 2222, network 170.100.100.2 is its interface. That's its serial interface. Now, as of right now, remember, by default, on a serial interface with no sub-interfaces, it will assume non-broadcast multi-access. So, interface serial 0 is where I'm going next. IP OSPF network, point to multi-points. Enter. And at that point, no pun intended, it should be good to go and networking up to router 1. So give it some time to form that neighbor relationship. We should see it pop up sometime soon. But while we're waiting, I'm going to jump down to router 3 and do a show IP route, because I want to make sure that it's receiving. As of right now, it's receiving the point-to-point network that's over here on router 4. It hasn't received yet the network from over at router 2. So while we're waiting for that neighbor relationship to form and that network to pop up, what I want to do is I want to show you the key troubleshooting commands that we've been using throughout this nugget, just to make sure that you can focus in directly on the troubleshooting when you're starting to work with OSPF. So first off, I've been doing show IP route all the time. That's just a given. Show IP OSPF interface will show you all of the interfaces that are running OSPF, so you can make sure that you encompassed it in the network statement. But more importantly, what type of network it's running. You see serial 0/0 is a point-to-multipoint network. There are your timers. Now in just a moment, once all of this neighbor relationship comes up, I'm going to mention how to tweak those timers if you want to. So this one is a great one to figure out what your timers are, what type of network you're running. So I've got show IP route, show IP OSPF network. Show IP OSPF will show you the facts about OSPF, what areas you have running, what interfaces, how many interfaces you have in each area. That's the ones I usually grab out of that command. And then my kind of nitty-gritty troubleshooting one is show IP OSPF database. Now, I must warn you before I hit the enter key, this is my nitty-gritty troubleshooting. It's when I'm doing a show IP route, things aren't showing up in the routing table, but my neighbor relationship is formed. So I'm going in my mind, I'm thinking, it should be getting those routes. So a show IP OSPF database will show me the entire topology table that OSPF is receiving. It's kind of like OSPF's roadmap. It's before it runs the SPF algorithm and chooses the routes that goes into the routing table. So when I'm troubleshooting, I should look in here and I should find out, what routes am I receiving? What routes am I getting from my different neighbors? And I'm looking right here. Here's my summary routes. These are LSA type 3s. These are the ones coming from other areas. I see 170.100.3.0, 170.100.4.0 is in the database. So I'm receiving these other routes. And at that point, if they're not showing up in the routing table, I can start getting into my troubleshooting. And now's a good time because I'm looking and I'm seeing that router 2 has not shown up yet. Router 2 should be, did I type in the area command on there? I might not have. Let's jump over to router 2 and I'll do a show IP OSPF interface. Let's just see. Aha, we forgot to type in, like I apply this blanket statement. I forgot to type in the command to encompass the Ethernet interface into the OSPF process. So let's go on router 2, router OSPF 1, and I'll type in network 170.100.2.0, because that's its Ethernet interface, and that is in area 1. All right, so at that point we should have those. I'm going to do a show IP OSPF neighbors to make sure that I'm forming that neighbor relationship good. I have 1111, it has a full neighbor relationship, and you know what? Interesting, look at this, X start. As of right now, it's starting to try and form a neighbor relationship with 3333. The question is why? The reason why, and it will never form, it's going to sit there in that X start state, is because when we did the non-broadcast multi-access, I went ahead and typed a frame relay map statement that allowed it to get to that neighbor. We shouldn't have that frame relay map statement in that case. And the reason I say that is because look at what's happening here, and this is the key I want you to see. This is why I love point-to-multipoint networks. See this right here? Let me see if I can highlight it exactly. 170, 100, 100.3. Look at the subnet mask, /32. That is a host subnet mask. So here's my point. In this point-to-multipoint network, when I enable point-to-multipoint on each one of those interfaces, that mode for OSPF, it will automatically generate routes for each one of the neighbors on my point-to-multipoint network. What I mean by that is that I don't have to type in a frame relay map. Let me grab my pen here. I don't have to type in a frame relay map for router 2's serial interface to map up to here and then back down to here to router 3. And you remember when I did the NBMA, I typed frame map IP 170, 100, 100-3. I mapped that IP to Delcy 201 so it could know how to get there. And I need that for NBMA mode. But I'm not doing NBMA mode anymore. I'm doing point-to-multipoint, which automatically fills those host entries into my routing table. So it will figure out how to get to those hosts, not via layer 2, not mapping IPs to Delcy numbers. It will figure out how to get there via layer 3. That's why we end up with these individual host entries in the table, is because OSPF will take care of it for you. This entry in my neighbor table, this X start entry, it's a bad practice to have it there. So if you're on the CCIE lab, be careful. You want to make sure you don't end up with that. That will stay there until I remove that frame relay map statement that I put in to make the non-broadcast multi-access network work. You get that key point? That's a big one between those two different modes. NBMA does not generate those host entries and requires frame relay maps, but point to multipoint will generate those host entries. So at that point, we have covered the major OSPF NBMA modes. Let me bring the slide back up here just so you can see what we've done. We went ahead and did non-broadcast multi-access to start off with. We then yanked it off and did point to multipoint, which dynamically discovers it. And as kind of a intermediary step, we enabled point to point, which is the easiest one to do. The ones we didn't cover is broadcast and point to multipoint, non-broadcast mode, and that's just because it is exactly the same configuration as Ethernet right here. You just make sure that you have a full mesh and type in IP-OSPF network broadcast and it'll work. And for this one, it's the same thing we just did, except you have to statically type in neighbor statements for that point to multipoint network to work successfully. Now there's one last thing I want to show you in this nugget, and that's something I promised from the objective slide. You may be asked to make not so friendly modes work together. For example, we just went on router 1 and we set it up to be a point to multipoint network. We went on router 2 and router 3 and did point to multipoint as well. Now you may find yourself in a situation to where you might have to set up router 1 as a point to multipoint network, but router 2 and 3 maybe as point to point networks. So the question becomes, how do you do it? Well, I'm not going to do the complete configuration here for time's sake, but here's how you'll make it happen. I'll do a show IP OSPF interface over on router 1, and we see that we have the point to multipoint network, and I want you to notice hello timer is 30, dead timer is 120. By default, 4 times the hello timer. So if you miss 4 separate hellos, you will consider that neighbor dead. Now we come down here to the point-to-point network and we see the hello timer at 10 and the dead timer at 40. So again, that 4-time interval is right there. But if we had to have router 1 being point to multipoint, router 2 and 3 being point-to-point, we're going to have a mismatch in timers. If for some reason you were banned from using an IP OSPF network command, which is not a very strange thing that could happen, what you'll need to do is you'll need to get into that interface that you want to tweak, and most likely you'll do this on router 2 and router 3. And let me show you the commands. Serial 0/0.1. I'm going to type in IP OSPF followed by a question mark, and we'll talk about authentication, things like that in the upcoming nuggets. But what I want to focus on here is number 1, the hello interval. If you want to manually adjust the hello interval, you can do that right here. You can type in the number of seconds that you want the hello interval to be. So let me scroll back up. We have a point to multipoint on router 1. If we are on router 2 and router 3 and we want to manually make that hello interval, which on them it would be 10 seconds, we want to tweak it to be 30, right here we would type in under their interface config IP OSPF hello interval followed by the number of seconds. You also have the dead interval right there, and you can set it to the number of seconds there as well. You also have the option of minimal, which will set it to a dead interval of 1 second. That might be to quickly time out a neighbor. And the final command is IP OSPF retransmit interval. And that's where you can type in the retransmit after the number of seconds in case it misses a packet. So IP OSPF hello interval, dead interval, and retransmit interval you can use to manually tweak the timers under the interface configuration mode for any router that maybe has an incompatible mode. This nugget is focused on one objective, really, and that is going to be making OSPF work across the non-broadcast multi-access network, or what I call the modes. It sounds like a horror flick now, doesn't it? 5 different modes that you can use to make OSPF work, and that is the non-broadcast multi-access, which is the default, point to multipoint, which is also the RFC standard. We have point to point, Cisco proprietary. I love that one. Broadcast to make the NBMA work just like a broadcast network. And then finally, Cisco's proprietary point to multipoint non-broadcast mode. All of those can be used in one way or another to make NBMA work successfully. We then looked at a lot of the show commands that we can use to tune OSPF precisely, and not only the show commands, but the commands we just discussed to tweak the timers in case you are asked to mix incompatible modes. I hope this nugget has been informative for you, and I'd like to thank you for viewing.